Hello everyone, this is the second video of Chapter 1, Powers and Exponents. In this video, you will learn how to write and evaluate expressions using exponents. We'll start off with the word power. The power is the product of repeated factors using exponents and base, where exponent tells you how many times the base number will be used as a factor, where the base means it's the number that's being multiplied. Another word we call a common factor. Here's an example. When you're multiplying 2 times 2 times 2 times 2, you're multiplying the same number over and over, where these two are going to be your base, where I see that I'm multiplying 4 times, so they write it smaller on top right side, and this 4 is representing that you have 4 factors. So in this case, your exponent is equal to 4. Here's a table how you say or write certain expressions. When you have 3 with 1 on top, this is called 3 to the first power, where it's saying that you're multiplying 3 ones. So that's how I know the factors are going to be just 3, where when you have 3 with the 2, this is called 3 to the second power, or you probably have heard it's called 3 squared. This means you are multiplying 3 2 times. This is very common that when people are seeing 3 to the second power, they write it as 6. And they are not same because 3 times 3 has to equal to 9. The third one is you call it as 3 to the third power, or you've heard 3 cubed. The cubed are the same word as when you are dealing in geometry, when you have a shape of cube. After the cube, there's no special names for it. So when you have 3 with the 4 as an exponent, you're just going to call it 3 to the fourth power, or you can just say 3 to the fourth. And sometimes they're just going to use a variable, and it's a very common variable that sometimes the textbook will use because n represent the numbers. So depending on how many times you're multiplying, that's how you can determine what this n will be. Here's an example number 1. Write each expression using exponents. To begin with, we are going to find what numbers are they multiplying multiple times. In here, it looks like I have -2, and I will put the parentheses, as well as you have 3. So -2 and 3 are called your base, where I need to know how many times are they multiplying -2. In here, it looks like they're multiplying -2 3 times. So that's how I know your exponent will be 3. When you have 3 multiplying 4 times, I could write 3 to the fourth power. And that's how I know this is how you write an expression using exponents. Number 2, they're saying, what if I have a variable? The variables are going to be the same, where in this case, it looks like I have a times the other variable is b. Now I'm just going to count how many times I'm multiplying a. It looks like I have once, twice, so this becomes a to the second power, or we call it a squared. The b has 3 times been multiplied, so I know this is going to be b to the third power, or b cubed. And this is going to be your answer of number 2. Here are a few more examples. So in here, part A, you have 1/2, and I'd like to put the parentheses whenever you are dealing with either negative numbers or when you have a fraction. Because when you don't have a parenthesis, if you write 1/2 to the fourth power without parentheses, this kind of looks like you have 1 to the fourth power over 2, which will get you just 1/2, which is not same as when you multiply 1/2 4 times. Thus, in here, I'll be putting a parenthesis so that way you'd know that I will multiply the whole group inside 4 times. Part B, they're saying now your bases are 4 and 5, where 4 you're multiplying 3 times, 5 you're multiplying 2 times. And that's how I know this will be my answer. The next one, same thing like as I mentioned, the variables. You just find what are the variables that they are multiplying. In this case, n and m are multiplied, and n you have 2 times, where m you have 3 times. So when I have n squared times m cubed, this is another way to express using exponents. Imagine that you have to multiply same thing 100 times. You had few options. Either you can write x to the 100 times like this to represent you're multiplying x 100 times, or you can literally write like this. This literally took me about 20 seconds, where if I actually finish this by expanding multiplying x's like this, it's going to take forever. So I hope you get an idea. Part 3, when they're asking you to evaluate, well, first, what does it mean by evaluate? Evaluate means either you're going to determine or calculate the numerical values. Another word, you will be using adding, subtracting, multiplying, and dividing in here to find out what is this expression will be equal to. In here, what they're saying is if you have negative 2/3 to the 4th power, your base is being multiplied 4 times. So if I expand this, I'll get negative 2/3 multiplied by negative 2/3 multiplied by negative 2/3 multiplied by another negative 2/3. Now you're going to apply the concept of how you multiply using fractions. When you have negative times negative, this becomes negative opposite, which is positive, and multiply with another double negatives. When you have positive, positive times positive will become positive overall. Now I'm going to multiply all the numerators. So 2 times 2 is 4, times 2 is 8, times 2 is 16, over 3 times 3 is 9, times 3 is 27, times 3 is 81. So that's how I know this will be my final answer. I don't really need a positive sign, by the way, so I could actually erase it. Similarly, we're going to evaluate the following 3 problems. When you have 4 to the 4th power, this is saying that you have 4 times. So take step by step. If I had 4 times 4, I'll get 16. 16 times 4, I'll get 64. 64 times 4, I'll get 256. And that's going to be my answer. When you have negative 2 6 times, let me expand it. Let me decide the sign first. I have negative times negative. The opposite of negative will become positive numbers. If there are an even number of negative factors to multiply, the product is positive. So I know the sign has to be positive. 2 times 2 is 4, times 2 is 8, times 2, 16, times 2, 32, times 2 will be 64. So again, if I get rid of this positive, my answer becomes 64. When they ask you to evaluate, as you see, I only get one number when I simplify this. The next one is when you have 1/5 3 times. Make sure that you know how to multiply a fraction, because in this case, when you're multiplying numerators by numerators, it becomes 1 over 5 times 5, I'll get 25. 25 times 5, I'll get 125. And that's how I know this will be my answer. In case you are given with a real-life situation, here's number 4. The deck of skateboard has an area of about 2 to the 5th power times 7 square inches. What is the area of the skateboard deck? It looks like in here they are asking you to evaluate. I'm going to evaluate what happens if you have 2 to the 5th power times 7. I forgot to tell you, when you write the exponent, please make sure that you write a little bit smaller. Otherwise, it looks like 25, which is not same as when you have 2 to the 5th power. So in here, if I have 2 to the 5th power, that means I will have 2 5 times at the end 7. So let's take step by step. 2 times 2, 4 times 2, 8 times 2, 16 times 2 is 32. So you're doing 32 times 7, which I will get 7 times 2, 14. 3 times 7 is 21, so 22. So I will have 224, but this time, since it's a real life situation, I have to follow the unit. In this case, they were using a square inches, so I'm going to write square inches, where if you remember, the square is the power of 2, so that becomes inch squared, looking like this one. And that's going to be my answer. The next problem, a school basketball court has an area of 2 to the 3rd power times 3 times 5 squared times 7 square feet. What is the area of a school basketball court? Imagine that in front of your basketball court, they're showing you how big your court is by using this expression. In real life, we try to make our lives as simple as possible. So in here, if I evaluate this, let me expand all of them so that it'll be easier for me to calculate. When you have 2 cubed, which means you have 2 3 times 3 times 5 squared is 5 times 5, and then last will be the 7. Calculating this, 2 times 2 is 4, times 2 becomes 8, and then 8 times 3 is 24. Let's see, what if I do this way? 5 times 5 is 25. 25 times 7 is 175. So when I multiply 175 with 24, let me write it on here. Multiply with the ones first. So 4 times 5, I'll get 20. 4 times 7 is 28 plus 2, I'll get 30. 4 times 1, I get 4 plus 3 is going to be 7. The next number will be using the 10th digit. So you're actually doing 20 times 5, and because it's a multiple of 10, let me just bring down the 0. So you shouldn't write anything on this side over here. So 2 times 5, I'll get 10. And then 2 times 7 is 14. But you have 1 over here. So 14 plus 1, I'll get 15, where I'm going to put 1 over here. 2 times 1 is 2 plus 1, I'll get 3. When you add all them, it will become 0, 0, and then 7 plus 5 is 12, and then you'll get 4. So I know that this court is 4,200 square feet. As you see, if somebody asks, just tell them this baseball court is 4,200 square feet, instead of you saying, oh, this is 2/3 times 3 times 5 square times 7. I love math, but I don't like anything complicated, so I prefer this way. Next one, again, they're asking you to evaluate using if A was 3 and B was equal to 5. So what I'm asking you is, instead of A and B, what if I replace with 3 and 5? In here, if I replace A with 3, it becomes 3 squared plus B was 5, so 5 to the 4th power. Let's evaluate this. So 3 squared, what happens if you have 3 times 3? If you're thinking about 6, it is not correct. 3 times 3 has to become 9, where 5 to the 4th power. So if you have 5 times 5 times 5 times 5, 5 times 5 is 25, and here's another 25. If I multiply like this, 25 times 25, that's 25 squared, which we will get 625. So plus 625 becomes 634, and that's going to be my answer. Number 6, what if you had A minus B to the 2nd power? And keep in mind, since there is a parenthesis, using the order of operations, you have to calculate the ones in parentheses first. If I had 3 minus B was 5 to the 2nd power, this means if I calculate the parentheses, 3 minus 5 becomes negative 2. When you have negative 2 squared, this is telling you you multiply negative 2 2 times. So in here, negative times negative will be positive. So 2 times 2, I get 4, and that's going to be my answer. This will be last slide. In here, if you evaluate each expression using C is negative 4 and D is 9. In this case, if you're using C as negative 4, do you remember me saying please use the parentheses if you have negative numbers or if you had fractions? Because again, I don't want you to just put negative 4 to the 2nd power because it looks like you have negative times 4 squared, which is not correct. So I'm going to put the parentheses plus your D was 9. In this case, you don't have to put the parentheses, but you can if you want to. So now negative 4 squared. So when you have negative 4 times negative 4, this will become positive 16. Plus 9 times 9, I should get 81. So in here, 81 plus 16, I should get 97. That's going to be my answer. The next problem, if you had C plus D to the 3rd power, again, this looks very similar to the last problem where you have to calculate the parentheses first. If I replace, so C was negative 4 plus you had 9 as your D, of this you'll have 3rd power. In this case, negative 4 plus 9 becomes 5. So 5 cubed will be equal to 125. I hope that you're not doing 5 times 3 because that is totally different than when you have 5 cubed. 5 times 3 would be asked like this, where the 3 is the same size as your number in front, where in this case the 5 is your base, where 3 is your exponent. And then the last one, what if you had D cubed minus C squared minus 2? In this case, let's do one at a time. D was 9. So 9 cubed minus, I see the square is inside of the parentheses. So in this case, negative 4 squared minus 2 at the end. If I do so, let's calculate the inside of the parentheses first. It looks like I have to do this part where negative 4 squared, this becomes positive 16 as what we just talked about over here. And then when you subtract 2 from here, 16 minus 2 becomes 14. I'm going to subtract from 9 cubed. So 9 times 9 is 81. 81 times another 9 becomes 729. So when you subtract them, this should be equal to 715, and that's going to be my answer. This is the end of the lesson. Thanks for learning with me. If you have any questions, please don't hesitate to leave a comment.